our last left-hand side, right-hand side identity sum, where we've got to prove that this side is equal to that one. Where do you think every single child could possibly get a mark for this whole sum?
Simplifying the 10.
How do I simplify the 10?
Simple.
I completely believe that this would be worth the mark. Because you have to get to sin over cos on this side. Now, let's go to this side, because maybe it wasn't necessary. Maybe this one went to sin over cos and you wrote 10 and it's fine. But there's a definite mark for knowing that sin over cos is 10 or 10 is sin over cos, somewhere. If that's all that you could get, that's what I'll take. Then, there are what type of angles here? Double angles, right? Double there. Double there. Oopsie, but cos square, sin square. It could be something. If this was a plus, then this would have been 1, but it's not. Cos square minus sin square is a double angle of cos, isn't it? Couldn't I manipulate the thing to be cos square minus sin square and get to a double angle? But now I'm trying to get your brain to practice this and see what to do and what not to do and where to go. We're trying to get to sin or cos or tan x. This side doesn't have a double angle. So that's why on this side I will not go to a double angle. I'd rather get to single angles, if you want to call it that. So I'd rather want to take the double angle into single. Because look at this. 2 sin cos is a double angle expanded. Can I not make that a double angle again? You can, but you're not going to. Are you with me sometimes? You're going to hear me say this often. It's true, but it's not useful. You're not going for the double angles. So, okay, let's try this. And this is now the fun and games or the horror of trigonometry. You never know exactly where you're aiming. You've got to start somewhere. So we're going to get to sin over cos. I'm assuming there's going to be some factorization here. Because otherwise, how am I going to cancel out here? Any ideas? Where would we go? Make the ones.
Get rid of the ones.
Get rid of the ones. How?
The top one substitute with sin squared
Okay,
x.
I was just wondering if you want to say cancel out, which you're not saying. So sin squared plus cos squared. How are they going to help me though? And then the 2x, we just said we don't want double angle, so we're going to write that as 2 sin x cos x. And then plus the sin square and minus the cos square sharp. Enormous sum. Aha! Things start cancelling out, I feel happy. And then this one at the bottom, I'm sure can cancel out, not? No, ma'am. Because the 1 is against sin squared plus cos square. Ma'am is saying, can this not cancel out? No, because of the pluses and the minuses. And then the cos 2x. Shouldn't I be doing something with that as well? Because I can't work with a double angle somewhere, just one double angle. I've got to get into single angles. So what would you presume we do to cos squared? Because there is 3 choices. Double angle of sin, there's only one choice, so I'm happy with it. But if it's a double angle of cos, you've got either cos square minus sin square, or 2 cos square minus 1, or 1 minus sin square. Let's just try any one and see if it works. Because remember, if we say that this is plus 1 minus 2 sin square, most probably that was not the one that you had in mind to use. But remember, any time in the sum when there's a 1, you can still substitute it with sin square plus cos square. Anywhere that there's a sin square, you can substitute with 1 minus cos square, and the same with cos square. So you can manipulate later on. Maybe you're going to have one extra step, one less step, that's fine. But you cannot just look at the sum and say, yeah, stop, step, and I'm done. You cannot. You've got to develop it. Okay, so at least that can cancel out. But then what about the rest at the top? I've got 2 sin plus the 2 sin x cos x. Okay, that's not going to do anything else. But what are we aiming for? Sin and cos, and we want to cancel out. So can we not? Factorize so that it can cancel out. Bottom part, is there something that happens there that can help you? We're going to have cos squared plus 1 sin squared minus 2 sin squared. I'm sure that we will be able to cancel a few things out. Somewhere along the line, we might want to still simplify and make sin squared into 1 minus cos squared. Okay? At the moment, we've got 2 sin x cos x. We've got sin squared plus cos squared. Maybe we should make it into cos squared and sin squared. Are you hearing what I'm saying? Put your feelers out, start practicing this. And then maybe it would be better to go cos squared minus sin squared. Is this helping at all? Aha. Doing a little bit more than the other one did. But absolutely you could go further with that one and later on substitute with something again. So that this is now 2 cos squared plus 2 sin x cos x. Help me with the factorization, because that's our only goal now, is to cancel out. So I can factorize by taking out a common.
Sin squared the top.
2 sin. Just sin. And what's left? Sin plus cos. So guys, you better get sin plus cos at the bottom. Otherwise it's not going to work for me getting there. Are you with me? I know where I'm aiming. Isn't it a help though? What am I going to be able to factorize here? 2 cos. What's left? Cos plus sin. It's just the other way around, and it's plus, so there's no problem. Happy on that? Cancelling out. 2's cancelling out, and sin over cos? So that we could have said left hand side equal to right hand side without writing that step over there. But at least if I could do nothing else, that might have been worth my mark. Knowing that identity, that tan is sin over cos. Right. Back into grade 11. Your first sum, normally in your whole trig part of your exam, starts off with the Pythagoras called butterfly sums. Butterfly sums meaning you've got to make a choice in your butterfly with one of those 4 quadrants. And your little angle is always there right in the corner. This was not the first one that I ever showed you, but this is the one where I say if cos 20 or whatever, sin of cos 10, is equal to P, find in terms of P. Does it come back to you? Find in terms of. And it doesn't have to be P, and that's my own abbreviation in terms of K, in terms of whatever. You should know after studying it a lot last year that this is the Pythagoras last one. It's not the one where I said to you, listen, if sin is equal to minus 4 over 5, and the angle can be between 90 and 270, you've got to figure it out for yourself first, that this one will be in the negative, so sin is negative, negative meaning that it's either in the 3rd or 4th quadrant. This one says I can only work in the 2nd and 3rd, so that means I'm definitely in the 3rd. Remember, that's the standard Pythagoras caused butterfly sums. So you chose that it was sin is negative, and I'm only allowed to use from 90 to 270, that's why this is the only option. Then we have our 2 sides that we put on the right places, work out the 3rd one using Pythagoras. Are you with me? This is a extra bit that they love asking. Ma'am asked it last year, you'll always get it somewhere in your tests. That if I say cos 20, where is my butterfly? 1st quadrant, how come? Because that's smaller than 90. I'm not measuring 20 degrees, but it's got to be in the 1st quadrant, that being 90. But then I still need to know whether whatever my angle is I've got to know which side goes where. Now, where are the two sides? It's 3 over. And it's adjacent over hypotenuse. I'm here, always there by the corner, right? I'm here and it's adjacent over hypotenuse, so this must be P and this is the hypotenuse. Is it coming back to you? Then you always have to find the third side using Pythagoras. Pythagoras, right? Fast. Now, what would the last side be? Remember, we took a few days to get into that in grade 11, but now you should already know this. What would this be? Root? Another 1 minus? Excellent. And please give Pythagoras the credit he deserves. You know it. You know if this is P, what would this be? If this was P, how you would swap it around, whatever. But it's Pythagoras. And then I can ask you whatever I like. If it's 20 or?
70.
70. Because remember that's what you were taught last year. 20 and 70. Now what was my question? Because 200 and, yes, because now remember you know that you've got to do reductions. The moment that it's not an acute angle, you do reductions. And you say 180 plus 20. Ding, ding, ding. Has to be 20 or 70 to work with this triangle. Can't ask you for a 50. Are you with me? I could ask you for a 50, I'll explain to you now. But then that would be cos 20, because 180 plus 20, but in the third quadrant causes negative, and then you just read off. Cos 20 is adjacent over hypotenuse, well you could have read it over there, cos 20 is P. So the answer is minus P. So the second one would be, if I asked you for sin negative 70, what's name testing? Negative angle becomes a positive, and the ratio is negative except for cos, and it's not cos, so. And then to work out sin 20, sin 70, can I just read it from the graph? Yeah, because then I'm standing there. And sin is opposite of our hypotenuse, which would still be negative P. Or if you wanted to, alternatively, say minus, not sin, cos 20, which would still be negative P, alternative. But now comes the question, number 3. Find sin 10. How can I find 10? Remember, just said I can't ask you something like 50. It's got to have something to do with 20 and 70, and this is why I'm doing the sum for you. Grade 11 work still up to here. But this, I need something else. Like double angles or compound angles. Now the compound angles I've taught you. Very often you can use 45 and 60 and 30 to get to angles. Is that going to help you for 10 though? Okay. But 17, 20, how else could I work with it? 20. 10 and 20, right? Feels like maybe you can do something. But you can't just make it a double angle. You've got to have legal stuff to do. 20.
Don't you put it 2 sin 10 over 2?
Think about it. Maybe 50. If I had said, let me help you just with another one. If I had said sin 50, wouldn't you have said 70? Are you with me? And then I would have been able to work with just 20, but I'll have to elaborate on that. Who has an idea?
30 minus
30?
minus 20.
Say again?
Sin 30 minus 20.
So how's that going to help you? Because 20 is available in the sketch, and 30 is a special angle. This one was fine. If I asked you for 50 and you went to 70 and 50, which I've got, that would be fine. 70 and 20, I'm sorry. So but this one we can then work with the special angles. Are you with me? You just have to get used to now also being able to work with compound angles and double angles. Let's do that. So this would be sin, cos, sin, 30, 20, 30, 20, and it's sin, so negative stays. Negative, sin 30 is a half, cos 30 is root 3 over 2. And then this would be cos 20 is p, and sin 20 would be that root over 1. I don't have to write the 1 though. Are you with me, everybody? Substituting from the graph, but it has to come from the graph, the diagram. And then I'm actually finished. I would like it to look a little bit better, but that's actually quite nice. This would be p over 2, right? That would also be over 2, but then it would be the root 3 times the root 1 minus p squared. Now guys, I would be super excited if you got there and left it like that. Because you can now make the two roots the same root, putting them together by timing them in. 3 minus 3p squared. But is that really much more simplified? I don't think so. And also with the roots and stuff, don't worry too much about roots. There wasn't a root in the denominator, even if there is. We're not going to worry about it if it was 1 minus root p squared in a square root in the bottom. We don't worry about that. But I'm trying to show you how we're going to work with compound and double angles, even in our old work, with Pythagoras and cos and the old work of the butterfly. Okay, you can see what I was aiming for. I could have asked you for cos 40. Happy on that? Let's make our own one quickly. Cos 40. How would I get cos 40 to work here for me? 60 minus 20 can work. But I would like you to see it double.
Cos 220.
Are you with me? Which one is going to work the best? Because remember, cos double angle can be either cos square minus sin square, or 2 cos square minus 1, or 1 minus 2 cos square. Please can I then train you to use the original one? You have cos. So let's keep it in cos. So rather go for 2 cos square of 20 minus 1. Cos 20 is p, so it's p squared. And that was definitely the fastest one. If you had gone for cos square minus sin square, would you have simplified and gotten here? Definitely. If you had gone for 1 minus 2 sin square, you would also get there, but with a little bit of work on your roots and your 1 minus p square and square root that you've got to go work with. You would get there, but look for the easiest one in the scenario that's been given.